Welcome to the presentation of our tank rover project. Our project's objective was to build a rover that has both manual control as well as autonomous functions, including following a target using color detection and avoiding obstacles using a LiDAR sensor.
So, with that objective in mind, let's take a look at our tank rover. So this entire robot is powered with a 12-volt battery. It is a sealed lead-acid battery down in this undercarriage below. It's held with a 3D printed battery holder, courtesy of Cody Greener, and supplies power to this power bus, which you have a positive terminal here, a negative terminal here, and each of those then power a Raspberry Pi, which is just under this shield here. You can see from here that it's right there. It also sends power to a Arduino shield here, which controls both the motor tracks as well as a buzzer and this LiDAR sensor and corresponding servo. And it also sends power up to the Arduino shield on the arm, which you can see right here is where the power comes in. That controls the robotic arm using stepper motor drivers and corresponding stepper motors. And each of the Arduinos are connected to this Raspberry Pi through USB cords like you see here. And each of the Arduinos communicate with the Pi via serial communication. The Pi primarily sends commands to the Arduinos, but the Arduinos are also capable of sending signals back to the Pi. So to connect the battery to the power rails at all, we do actually have a master switch right back here. And while the master switch in and of itself turns everything on, it should be noted that the Raspberry Pi should be shut off from VNC Viewer before the switch is flipped. So without further ado, let's see this in action.
So the first thing that we see after we start running the program is this GUI that we programmed. It allows us to switch between a manual control of the rover as well as an autonomous feature. So we'll start by explaining the manual control.
So now that we've got the Wii Remote connected, we can control the robot manually using different buttons here. Under normal circumstances, you can control the robotic arm using the direction pad in several different orientations. You can also turn just the arm left and right. And if you see in this shot, I can open and close the hand, though it is a slow process. It's probably a little hard to see from this distance, but you can tell the hand has grown closer together in the video. So you can also open it back up using the A button. And then you can even drive the tracks around by holding the home button and using the direction pad. As shown here. If you want to disconnect the Wii Remote, then you can do so by pressing plus and minus at the same time. And if you want to jump back into the manual code, you'll have to hit the manual button again to rerun the connection. So the way this control is possible is that the Raspberry Pi will pair with the Wii Remote over Bluetooth and send signals over USB cable up and around the arm to this Arduino Uno here. And whenever the Arduino gets a signal to move, it activates this relay, which then connects the 12-volt power to the Arduino CNC shield. And this is for the fact that under normal circumstances, the shield is constantly getting power, or constantly sending power to each of the stepper motors, even when they're not moving. So to avoid draining the battery, we have this relay equipped because with worm drives and our current chain setup here, we don't actually need power in order to keep the arm in a specific place as well. So each of these chips right here is a stepper motor driver that connects to each one of these 4 stepper motors. We have one here to turn left and right, one here to move the shoulder of the robotic arm, one here to control the elbow, and one up top, a smaller one, to control the hand. And as you can see, the hand also, since it's a different kind of stepper motor, has a separate driver that actually takes commands from one of the purple drivers, but transforms it into a signal that this smaller stepper motor can interpret. Also, we are able to control the tracks by 2 motors that are back here. Each one of them is wired into a Arduino L298P shield, which you can just see the edge of down here. So the Arduino then runs this shield, which just enables the 2 motors back there to be controlled from signals from the Arduino and the separate 12-volt power supply directly from one of the power buses. So this same motor shield also controls the servo motor and reads data from this LiDAR sensor to navigate around obstacles during autonomous function, which we'll show you in this next part. Now we are in automatic mode, and the robot will look for patches of red. If they're large enough, it will roll toward those. So as you can see, if I move this blanket around, it will actually follow it until it feels like it's close enough, and then send a beep to let you know that it's basically reached the object. So you can see if I back up a little bit, and we'll try finding it again. Get far enough away from it. There we go. As you can see, it feels like it's gotten close enough. If I make the object smaller, it will attempt to get closer because it takes up less of the picture. So as you can tell, it will still follow the red. You can also see whenever the robot tries to go forward, the LiDAR will take a sweep just to make sure no object's in front of it. If an object is in front of it, it can actually navigate around it, which we'll showcase in this next part here. So as you can see, we're trying to find the red. And once it does pick up the red, the Raspberry Pi will send a signal to move forward, and the LiDAR will do a sweep to check for any objects. Once it detects a potential object that could be in the way, it'll actually navigate around it and keep coming. Until it's accomplished its mission.